So hello everyone. Let's do this quick problem on power ratios of powers in the stator. Okay. So let's read the question. You can yourself try the solution and then cross check your answer. The question is on your screen. So let's begin the solution for this. Oh, yes, I'm repeating the question. Okay. So what is given? The power input to the rotor of 440 volt 50 hertz 6 pole 3 phase induction motor is 80 kilowatts. So power input to the rotor means P2. So P2 is 80 kilowatts. So again, you should be familiar by now with the notation. What is the meaning of P2? What is the meaning of PCR? What is the meaning of PM? All that we have discussed in the previous videos. So if you have not seen them, I advise you to see the other videos which are in this part of this playlist. Okay, so P2 is 80 kilowatts, that's what is given. Now, the frequency is 50 hertz, that's also given. And if it is a 6 pole machine, poles are 6, so then what is the synchronous speed? So it is 120 F by P, 120 into 50 divided by 6. So 6 goes 20 times, and this is 1000 revolutions per minute. I just calculated the synchronous speed. Maybe this will be useful for us in the later part of the problem. Let's continue. The rotor electromotive force is observed to make 100 complete alterations per minute. So we are talking about rotor electromotive force, which is E2. It is making 100 cycles per minute. So from this, I can determine what is what is E2 makes. 100 cycles per minute. I can determine what is the frequency of the rotor. Okay, so the frequency of the rotor is defined as S into F, but that is 100 cycles per minute, or 100 by 60 cycles per second, or cycles per second is hertz. Okay. So from this I can find what is F. Okay, so or what is S. F is already known, that is 50. So 100 divided by 50 into 60. Okay. That is 1 by 5 into 6 is 30. So 1 by 30 is, I think, 0.0333, or it is 3.33 percentage. Okay. So this is the slip of the motor. So this is what we have already solved. What is the rotor speed? So rotor speed is straightforward now. NR equal to NS into 1 minus slip. Okay. So NS is 1000 into 1 minus 0.0333. Okay. So with how much will it be? So let's use a calculator. One minus 0.0333. So into 1000. So 967 RPM. I'll just round it off to 967. Okay, so 967 revolutions per minute. Okay. So this is the answer to the second part of the question. Now rotor copper losses per phase. Okay. So how do you know the rotor copper losses? Just that. So this is rotor. Input is 80 kilowatts. This is P2. Therefore I know PCR, and then I know of course slip is 3.33%. So, and the output will be PM, whichever that is 96.7% actually, 67%. Anyway, so now let's calculate that. What is the PCR? Okay. So PCR is nothing but 3.33 percentage of 80 kilowatts. So 80 multiplied by 0.0333. So that is 2.67 kilowatts. Okay. So this much is this is for all three phases. So but in the question per phase. So rotor copper loss per phase is equal to 2.67 by 3 kilowatts. Okay. So which is equal to divided by 3. So that is 0.888 kilowatts or uh, 888 watts. Okay. So each phase of the rotor is losing 888 watts. Okay. So the loss is in the form of heat, as you know. So I think this is the problem. So let's try to see more problems based on this.